Okay, so Leetcode practice time. Diameter of binary tree. Two goals for this video. The first one is to see how to solve the problem, and the other one is to see how to behave during a real interview given the specific question. So let's get started. So usually the first step during an interview is to try to understand the problem and also try to ask clarification questions in case you have something you want to learn more, or you have something that is unclear to you, and also at the same time think about the edge cases. So in this case, let's first read the problem. So given a binary tree, you need to compute the length of the diameter of the tree. The diameter of the tree of a binary tree is the length of the longest path between any two nodes in the tree. So this path may or may not pass through the root. So it doesn't need to go through the root necessarily. So let's take a look at the example. So given a binary tree returns 3 for this one, that's because, okay, so the length, which is the length of the path 4213 or 5213, okay. Okay, so I think we understand the problem now. I would say one edge case is what if the root is empty? It's a non-pointer, so that's only edge case I can think of at this moment. And let's see how the next step after understanding the problem is to find the solution. So at this time, try to find the solution and also communicate with your interviewer to explain how your solution is going to work and do some necessary time-space complexity analysis. Get an agreement before stepping into the next step to do some solid code. So let's see. So for this one, I would say it is a Dfs problem, and for a certain node, you try to find the longest path on the left, with the longest. So you try to see the longest path or the depths on the left side for a certain node, and you try to see the depths, which is the longest path on the right side. And the longest path on the left side plus longest path on the right side for a certain node is pretty much the longest path currently, which passed this node. And if you enumerate all of them, then of course you are going to find the solution. And for this one, it is a deep first search problem. So of course the runtime is going to be all of n, and is the number of the nodes within the tree. So space wise, I would say it is, so since we use a stack, so space wise it is gonna be linear to the length of the tree. So I think we should be good at this moment. So let's get started to do some solid code. So the next step is to do the coding. In this part, people will see your coding ability to turn the IDE into solid code. Thus, the speed would be a factor to be considered, and also the correctness of the code, and of course, if the readability of the code. So let's start to do some coding work. So first of all, edge case checking. If root is equal to none, then we are of course going to return a 0. Otherwise, we will do a DFS on top of this. Let's see. So yeah, so okay, so I think the return value of the DFS may not really solve the problem, so let's define a private thing. Let's call it longest path. Okay, so at the very beginning we will set the longest pass to be equal to let's say if it's equal to 0, okay, and then we define a function. Let's say if it's public void depths. So in this one, we are actually going to, for a certain node, we are going to try to find the depths on the left side and the depths on the right side. So it's a root. So so if longest pass, so let's say longest nose, let's define it, nose on longest pass, okay. Yes, so no, it is actually, we will see nose, if it's nose on longest pass, it should be initialized as 1, and we will see, we will call it depths on top of the root, and also finally we are going to return nose on the longest pass minus 1 as the length of the longest pass. So for this depths function defined, it is a recursive function. So the exit of it is if root so if root dot left is equal to none and the root dot right is equal to none, then you definitely need to return a 1. So nodes on the longest pass is just 1. So otherwise we will say, okay, dfs depths, so if, let's say, int left longest is equal to 0, let's say. Not really. So this one, it shouldn't return void, it should return an integer, which is the length of it. So left longest is equal to 0, and if root dot left is not equal to a non-pointer, then we are going to try to traverse the left part, which is root dot left is equal to left longest, or left depths. Yeah, let's say it's left depths, and if root dot right is not equal to a non-pointer, then it's not equal to a non-pointer, then the right depths would be equal to depths root dot right, okay. And now we will see, okay, so nose on longest pass is equal to mass.max nose on longest pass. Another option is left depths plus the right depths plus 1. And regarding the depths of the current thing, it is going to be 1, which is the current node, plus which one is maximum, the right depths or the left depths. So I think we are mostly code complete. Let's do some testing. So for testing part is the time for you to explain how this piece of code is going to work by going through a simple example, and also try to think about some other test cases to try to have good enough test coverage. So let's take the example given in here. So for this tree, 1, 2, 3, 4, 5. So first of all, we initialize nodes on longest path as 1 and jump into this recursive function, and the left is not equal to none. Oh, okay, it's equal to none. And so of course this is not a leaf node, and we are jumping into, so, and the left pointer is, the left child is not equal to none, so we are going to jump into this part. So we call depths on this node, on this node, which is 2, and it is not a leaf node, and we are going to call this one, call the depth function on this thing. So for this one, it's a leaf node, it is going to return 1. So here, after the function return, it is going to return 1 here. And same for when we call the 5. So both are 1. So nodes on longest path is equal to 1 plus 1 plus 1, which is 3. When we finish visiting the left subtree here, the left subtree with the root as the left subtree for the root node, and we are going to return 2 here, and similarly here we are going to return 1. So similarly we are going to return 1 for this, and so it is going to be 2 plus 1 plus 1, which is 4. So we are going to set nodes on longest path as 4. So 4 minus 1, which is 3, we are going to return. Okay, I think it mostly looks good to me. Let's give it a try. So regarding the task case, I would say definitely set up some tree, some general tree like this, and also set up a tree which with the root as a non-pointer, which means empty tree. Okay, so it accepted this piece of code. Okay, so it also passed the submission. Okay, so that's it for this video. I hope you like this video and find it a bit helpful. So thanks for watching it, and I'll see you next time.